To control the robotic arms and conveyor belts of a complex industrial facility, you need a highly precise virtual brain. In automation, that brain is a programmed PLC simulator. Today, we are going to take your computer from a blank desktop to a fully licensed, configured, and simulated ladder logic environment using Siemens software. Before we begin, you need two things: a registered account on the Siemens website and a computer with at least 8 GB of RAM to handle the heavy processing demands. Setting up this specific virtual lab gives you the exact tools used by industrial engineers, allowing you to build and test automation logic without purchasing thousands of dollars in physical hardware. Step 1 is acquiring the core software. Navigate to the Siemens Industry online support site, log into your account, and search for the Step 7 Professional Trial version. You will see a list of 5 distinct setup files. Download every single one of them into the same folder before you attempt to click on the Start application. When you initiate the installer, the software will immediately prompt you to restart your computer. Do this and then click the Start file again to begin the actual installation. This mock-up of the TIA Portal installation interface shows a crucial decision point. You must select the typical installation option. Choosing Minimal to save space will permanently disable your ability to run simulations later. Click Install and step away. This process can take up to 30 minutes. When it finishes, check the box that says Restart Later and exit the setup. Taking the time to install the typical package ensures that your system downloads the exact virtual hardware libraries required to run your simulator. Now we apply the software keys using a utility called SIM which activates the environment for lifetime use. Open the utility and execute 3 quick steps. First, click Required Keys. Second, check Select All. Finally, click Install Long. If the system asks to overwrite existing keys, click All to confirm. With the keys installed, you can now safely perform the computer restart you postponed earlier. Once your computer boots back up, open the S7 PLCSIM installer. Follow the exact same procedure. Select the typical installation path, finish the setup, and perform one last system restart. Without these activation keys and the PLCSIM module, the TIA portal operates strictly as a text editor. The PLCSIM installation is what actually processes and executes your code. Launch TIA portal and click Create New Project. Name your file, set the save location, and click Create. From the left-hand menu, select Configure Device. Click Add a New Device and expand the Controllers folder. For this setup, open the specific S7 1200 model catalog. As shown in this schematic diagram, selecting the correct firmware version is critical. If you pick a firmware version lower than 4.0, your simulator will not function. Once your CPU is added, look at the device overview panel. Note the starting addresses for your inputs and outputs, which typically begin at 0.0. You will need these specific addresses to write your code. Matching this exact firmware version during hardware configuration is the strict requirement that allows TIA Portal and your PLC Sim engine to communicate with each other. Before writing a single line of code, we need to prove that the two programs can talk. First, open your PLC Sim interface separately and power the virtual simulator on. In TIA Portal, click on your CPU, then click the Download button to push your empty hardware configuration into the waiting simulator. Click Load, then Finish. Now click the Go Online button at the top of the screen. This tests the direct communication link between the engineering software and the virtual PLC. This logic flow diagram illustrates the necessary system handshake. You are looking for the status indicators to flash orange, then lock into a solid green light. Establishing and verifying this connection first ensures that if a sequence fails later on, you know you are troubleshooting a logic error rather than a broken system setup. Disconnect by going offline, then navigate to your main OB programming block. Insert a normally open contact and label it with your starting input address, which is I0.0. Next, insert an output coil on the right side of the network. Assign it your starting output address, Q0.0. Click Download to push this newly written logic block to the simulator. Go back online, start the CPU by clicking Run, and turn on the monitoring mode to watch the live data flow. To trigger the logic, expand PLCSIM to create a new project file and open a SIM table. As seen in this split-screen layout, we type our exact I0.0 and Q0.0 addresses into the data table. Now for the live test. Check the box next to your input in the SIM table. Instantly, the ladder logic inside TIA portal illuminates green, and your output coil activates. Seeing the logic block react to your forced input confirms that your local computer is now a fully functional live engineering laboratory. You have successfully downloaded the core files, locked in your licensing, mapped the hardware constraints, completed the software handshake, and executed a live logic simulation. Look at this functioning automated floor. Now that your virtual PLC is actively reading and writing live data, the next logical step is connecting it directly to a 3D factory environment just like this. Subscribe to the channel so you don't miss our next tutorial, where we will bridge this exact PLC logic into the factory I/O software. Mastering this sequence gives you the ability to design, test, and debug complex industrial automation from anywhere, entirely through software.